I will not give a lecture on my travel, although that would be much more disastrous than anything else could be. Now, in a situation like this, going back for almost 40 years, close to, you have to think, oh, what did happen? So I looked back through the files, and Eva Gundel, my secretary, as well. So I tried to fuse the history of Franz Ramaekers, with the present and the future. Because the future is always that was really interesting in scientific research. So, at the time when this young that was wrong. Okay.
There you go. Wait. No, wait.
Is it this?
Here.
Press forward here.
It's this one. And now use.
This backwards.
Backwards, forward.
Okay.
No? Okay.
It was at the time, nobody could predict that, where things came together. There are these moments in time when the right things come together and the right people come together. So I was sitting in a railway train back from Brussels to Cologne at the time, and I met a person who just had come back from Harvard and also gave a lecture in a different place in Brussels, Klaus Weber. Most of you will know them. He died a year and a half ago. So he just, and Mary Osborne had gone to the Max Planck Institute Göttingen. I was in the cancer center. And then in the railway wagon, we showed the pictures, what to do, and we said that his very serious chemistry, not just biochemistry, real chemistry, should perhaps be fused with the light and electron microscopy and all the techniques that we were central in. So from there on, we, and also Franz Ramaekers, was part of that system. So typically, on the first paper on that, Mary is there, Klaus Weber is there, and of course, and we should now remember him as well, Hans Blumendahl, because Hans Blumendahl was, as you know him, not for his Jewish songs, but also for his history. He was born in Fulda in Germany. I also tell this now for the first time to the public, I had made the proposal to have him an honorary citizen. They didn't want that. So, but Hans Blumendahl, most of you will know him, he was late in science, but he also was clever in the sense of what could be solved. So clearly, the most simple type of cell that you could think of was the eye lens. No nucleus, very little other things. So that's where Franz Ramaekers worked on. He came to Heidelberg, and in this paper, which I just show here, that were some of his pictures in the first. So the classic things, at the time already classic, since 2 or 3 years. You remember that was actually attacked sometimes at Cold Spring Harbor meetings. Some of the traditional electron microscopists didn't like that, etc. So actin, myosin, and tubulin, and then it came to the eye lens, and you were surprised how much of a newly discovered protein that was vimentin. The people ask, you still know what vimentin means? Oh, that's what I'm accused of. That's what Werner Franke, people are really furious about me with his Latin names. They don't like my Latin history, which are 9 years at the Gymnasium in Paderborn, Westphalia, and 6 years of Old Greek. Vimentum was that what the Roman housewives, so to say, when they went shopping, it was from the willow trees, which are not branched together, so they did put everything. That's exactly how vimentin filaments very often look unbranched, very parallel, very ordered in a way. So that was how these cells were loaded full. Every other cells in the eye were negative. Only the cornea here, a bit of the cornea, was positive for keratin. That was all. And also then, in the band up here, it was a very clean, simple system for characterizing the protein, and also then to find it in the electron microscope. Down here is a microtubule, and up there are these numerous dense loaded vimentin filaments. And this is how they then look in cross sections. You see that tiny hollow at the time, but didn't know this really what it means. They're really hollow. So you see how loaded these cells are of that protein. So Frans had made a lucky choice then to continue work. So when I had to prepare this, it was crazy. We have what is called the Dutch board in the laboratory. They're all theses. For some reason, I received many theses, so this was from Frans. And then the publication with Blumendahl in the same year, 82. Okay. Until 86 here. So there was here a Cold Spring Harbor meeting where they presented their findings. So it was a full program then going on. And this now I show you we continued that, of course. There's always a person continuing. Beate Straub, one of the youngest German now pathology professors. So here we characterize more of the proteins. Two major catenaries in the lens. And then you see here, I cannot, no time yet, now to go to all these double localizations. The lens has one of the most characteristic, wonderful, short edge, long edge, etc. It's almost like a painting. Here you see, for example, the gap junctions between the cells, etc. I'm late, so I have to hurry up and just want to show you this. And you have seen the citation, it's a Journal of Cell Science paper, but this was all there. All you see here, very clear patterns of the plasma membrane-associated proteins only. So even there is tremendous order. Then, of course, we have all these quacks I have to mention, you know why? Because he sequenced it. You will know these names I've written up here. I not so much. Weiz, Nijmegen, Maastricht, Nijmegen, Leiden, Amsterdam, Antwerpen, Nijmegen, Amsterdam, Groningen, and yeah, I have one more. I have some more, not yet in slides. So I just want to show you the Dutch board with all the theses and the papers makes one whole row. And also again, I have to mention then that Hans Blumendahl, and in honor of Hans Blumendahl, was created that Hans Blumendahl Lecture Prize. So today, I will talk about what has happened since. And I confess that I have been sponsored by the Deutsche Forschungsgemeinschaft and all these money givers a lot in my life, but no longer since a couple of years. Why? Franke with his Latin names, ha ha ha. It's in our textbooks, as if it were wrong if my findings are not in a textbook. They are not in textbooks since decades. And this is why I thought I oblige you to show you some of the real markers. So most of the talks I give are surrounded to such a theme. And just to show you, and this is also in the Netherlands, some of the merits of Frans, a lymphatic tissue looks lymphatic, was a patient. But when if you take the right markers, it's a metastasis of a carcinoma. So you don't see it with conventional techniques. So there are many examples of this, or fat, body fat inside. Nothing goes on, No, a lot goes on. It turned out then to be a metastasis, a spread out metastasis of a colon carcinoma because it was positive for cytokeratin 20. So with these, you get something which I once called in German, Gehalt vor Gestalt. So far, the whole pathology was, it looks like, so it will probably be such and such a cell, or it will be derived from such and such a cell. Now we are completely on a second line of recognition, and that is the molecules. There are many tumors which are round cell sarcoma or round cell something. That means you don't see any morphology in that, but you see these things with, of course, the right markers. Just to give you one early example, there was a teacher in Mannheim near Heidelberg who had for years hands, and so there was a wounded when I was doing something in the garden. It was liquid, like a damaged hand wound, and sections look like this. What is this? The dermatologist didn't know. However, he was then in a group where the tumors were checked, and this was, again, I show you cytokeratin 20. What's that? So then people, I also show you then, you can see even individual small metastases on their way through the lymphatic system. So it turned out a colon carcinoma metastasis, again, metastasis to the skin. So the most bizarre things can now be, at least examined by molecules. And I will just show you two examples of the evaluations which are mostly printed in the American Journal of Surgical Pathology. The American ones, they do this very frequently. So they take what they have, 50, 100 pathologists, and spread them out. Second voice diagnosis. And then funny things from the German pathologists don't like that. You will see this, that's German pathologists. It's why? It's the law. If you have in the Anglo-Saxon law 3 independent voices coming to the same conclusion, diagnosis, it must be right, In Germany, everybody is God. So, and this, so it looks then, a few examples. And you see what they have done to come from the initial diagnosis to the right one. So you see here, cytokeratin negative, cytokeratin 120 this. Oh, damn it. Yeah. Or here vimentin positive. And so metastatic carcinoma turned out to metastatic melanoma, and so forth, and so forth. And this is no exception. You will see that's a German study which was also published in the American Journal of Surgical Pathology, but also then, an extract of that was also in a German pathologue, and you will see why this comes to the problem. And it still is a problem unless enough markers, the right markers are being used. Just look down here, a lung metastasis of a kidney carcinoma, only 20% right. That's everywhere. That is not only in Germany. There are here 21 in a myxoid dermatofibrosarcoma, and so forth. I just show you this to show you the real truth about diagnosis. Nobody, questions that. That is not usually not controlled, etc. And you can conclude from that I would very intensively request. Very quickly an insert. I've written about me here something of my second and third personality. And that has to do, of course, this is why I have to say something. And this is, always when I give a lecture, I give something critical to the audience. This is Dutch. This is my wife. And she was in 2 Olympic finals. She was the German champion in the discus throw and the shot put. and in the pentathlon as well. You will see I gave her name. It was in discus. She had to beat the world record holder in the discus to win the championships. That is the book which she wrote after I had collected from der Wissenschaftsrat the secret protocols that still existed in the GDR, but also in West Germany. And quickly, what is her name? Her name is Brigitte Behrendonck, like a big part in Nijmegen as well, but also perhaps other cities, because her father is from the Niederrhein, as we say, near Nijmegen, and then went to Jena, etc. So she wanted to come, but she, I explained this, is now somewhere following Goethe's traces with her friend in Eger, in former Bohemia, now Czechia. Now I have, however, to mention it to you, and I have to use this situation to say, what did happen to the Dutch ethics? There were Dutch female persons in the GDR, I have discovered that, preparing for Olympic Games by using virilizing, it's not doping, that's virilization. They know this. There were people, they could also name some of them, but in this country, not much has ever happened. This guy, Eric De Bruyne, now buried in Ireland, he was also several medals winner, etc., was positive twice. Second time he was then, but it didn't really, he was just banned. This in particular, Ria Stahlmann, Olympic gold medal winner in 1984 in Los Angeles, she has now, after 34 years, she admits, after so many decades, nobody in this country has brought her to that ever. And although in the same year when she won the gold medal, you see this down here, she was caught at the Mexican-US border with 800 tablets of stanozolol, which is one of the stronger. Nothing has happened here. And thus you can discuss with you. I could give you a full lecture about the nationalistic treatment of sports in the Netherlands. This is, for example, the German, when she was junior, Claudia Losch, the shot put winner in 1984, parallel, and 3 years more, same person. So I can give like this. How can, and when my wife came back from Mexico, where she made the final, and said, they all look different now. They have deeper voices, hairy, number of strange things. Then I explained this to her. We were in the same club. And then she said this one sentence that stuck me for my life. She said, so, and what do you scientists against that? Because, according to her thinking, scientists are obliged to make public, attack every abuse of scientific results. And this is going on. With this kind of sports, this is the person I just go quickly for is now what they have to pay. It now comes out, and I publish it. I'm the only person, but people are against me, And I publish the confessions of the former sports medicine person on the extremely large clitoris, etc., etc. So we have these things, and they will all be published by my wife and me, so that at least once the truth is in history there. Yeah. Now we come to the most interesting part that goes on, starting from Marilyn Farquhar and George Pollard, with the publication 1963, which is still cited over and over again as the basis for today's junctions. Junctions also as the anchorage sites, structures of the filaments. Huh? What's this? Come on. Yeah. So that all happened in this situation when George Pollard in the middle here, In the middle is Marian Farquhar. Günter Blobel also died a year ago. This is now, I had to give her honorary talk in Bucharest. Maya Simeonescu, that's her also dead husband. Nicola Simeonescu, this is David Sabatini. And this, for example, is the only still living Nobel laureate of these. This is Christian de Duve from nearby Belgium. They had, after the Nobel Prize was given to George Pallade, he was invited by the Carters, the president, and was asked, what can we do for you? And he was originally a Romanian, but now since decades in the state, he said, if you want to do something, please, for the young people at the time, Ceausescu's Romania. And then, indeed, the United States sponsored a modern research institute, which still exists, still a nice one. And this is the opening lectures, with 6 here in front, they were given at the time. Again, that's it. And that's it as it is in the textbooks. 4 major tight, adherence, desmosomes, gap junction. So we know major proteins. And I say, this is in this year, 2018. Yeah, a pen that is still treated this way. Why? That's not even a tenth of the truth. So at the time, together with Pierre Drochmans, whom some of you will know, we isolated desmosomes. I will quickly go over this. Immunoelectron microscopy, which I considered light microscopy for desmosomal proteins. And also we then combine cytoskeleton, filament staining, with anchorage, that is junctions. So with those techniques, this was a cover in the last Cold Spring Harbor Perspectives book. I have discovered so many Latin names, other junctions, not minor ones. Some are very important. Important, and this is now what it comes to. I mean, what was done in 1980 when he came back from Heidelberg to here? He said, no, it's not so that here are the basic researchers and there are the medical people and they feel happy about it, they may use it as a marker or not. No, they have to sit together, they have to lunch together, they have to have everything together from then on. That's what we did, of course, here and Klaus Weber and Mary Osborne of Göttingen. We joined forces to solve those questions. And here, for example, it is nothing so important for the progress as this interaction. I just can give you only a few examples. In red here, rectangles are new proteins in the last couple of years. The years always indicated there. This, for example, Franke with his Latin names. Composite junctions, they are in the intercalated disc where the cardiomyocytes border on each other and where also the myofilaments are anchored. This is a double labeling, and that's something not allowed at the time. For example, desmoplakin and cadherin together, what's that? Yeah. So we had co-localization, not only light microscopically, but also electron microscopically, over all these intercalated discs, the composite junction, composite Y, it was composed of adherent junctions and desmosomes and a few others as well. So something totally new, but a major thing. I was not too enthusiastic. Then what happened was the following. In 2005 already it was discovered, and there was a note in the cardiology, cardiovascular literature in the States. We also recommend treatment of patients with IRVD with beta blockers and angiotensin converting enzyme inhibitors, and that all patients with this situation be screened for a mutation in the gene for plakophilin 2, one of those which I had just discovered a few years ago. Because this is present in more than 1/3, it's actually close to the half of all patients with IRVD, and may be helpful in the management of first-degree relatives. That is also the case in this country, and I was almost about to telephone the person who in this country is at the meetings that I had to organize. He was first in Groningen, now he's in Amsterdam, with Van Tintelen. Why is this country so important? The Netherlands is important because here you have in certain parts of the country religious sects, or what you call them. So there you have something that the Netherlands is like to call inbreeding. However, with that you then have higher rates. Actually, you have parts in the Netherlands where you have one. Okay, at the first meeting that I organized in Heidelberg, it was given the figure 1 to 5,000 people in Europe and the States. The second meeting 4 years on, it was in Finland and also in the Netherlands, 1 in 200. Not all suffer from sudden death, which is the most frequent disaster or severe, but that's what you can determine then by DNA. And soon, that's the American way, a company was founded as an outsourcing of the NIH, where such things you can send your DNA, and they will test this for you, and you will see the names, how I will diagnose desmocollin 2, desmoplakin, desmoglein 2, plakophilin 2, plakoglobin, and the down one also. They're all from our laboratory. They're all such strange composite junction markers. And also, so that you see that I'm not erratic about this, when I read that paper in genetics, I thought, there was that family tribal plan also given. Do you know that person? So I inquired with the pathologist, and right, it was Gerd Jacobs, a shot putter of the GDR, who then died from that very soon. That's the second. I'll be fast. Okay. Yes, I'm afraid. I quickly. So you have all this. I will now go to one of the others. I know. I'm afraid. Which I called Aria tesserata, and I gave them the title. Tight junction proteins are not alone in tight junctions. They're almost everywhere. And I've had 2 meetings in Japan, the home country of tight junctions. And Sashiko Tsukita is now holding this. They had to agree to this. Let's describe this here. You will see this. Occludine, claudine, more than 25. And then we discovered that these are also in the uppermost layer of the skin. And if you, however, do good immunocytochemistry, you see occludine is not, it's also up there in a region, co-localizing. And here, for example, in the gingiva of the teeth, you see here is nothing. Here, however, it's claudine 1 now, doesn't it? However, here is claudine 4. And this is a double, so 2 different tight junction proteins are in different regions, etc. So currently, we are developing a new world of tight junctions. They are not as dense together as in occluding junctions, but mass-wise, this is much more. And this is what I like most. And EM technician in my laboratory has to learn that to the extreme. So here are desmosomes, it's tongue, mucosa, and here is occludin, a tight junction protein. It's in between the desmosomes all over again. Or in a different part, you see it here. They are all occludin and claudins, and this is now a free fracture, these are desmosomes, and these are, in this case, mostly occludin and claudin in the esophagus. I cannot tell you why, it's the most important application at the moment for the so-called disease called eosinophilic esophagitis. We see these colocalization, and now, in the tumors, they're not homogeneous. These are bigger tumors, but if you do careful immunolocalization, you see that within the tumor with such and such markers, there are small regions like this here, say claudin positive. What is happening? In most tumors, you have a heterogeneity, and sometimes it's only 3-4 cells. So then, after after a good, successful therapeutic treatment, hooray, after 5 years, tumor is no longer there. And then comes something, might be published, there's an independent tumor. Now it's not independent. All what I have seen so far is one of the early hidden tumors, who then, that is evolution, when the bigger main tumor is away, he has the advantage of being able to grow. So you have seen all the others. There's now a world of structures of importance for many diseases, in particular also tumors. And I had to discover that I'm the only one